Why do scientists actually need to plan experiments? It's part of a big picture. Scientists plan on how to gather evidence to answer questions that they can make an educated guess that can be tested. Scientists also need to gather and record information to test out their hypotheses. The information that they record and gather is called data. It's all part of the procedure called the scientific process. And the scientific process can be broken down into 6 simple steps. You can come up with a question, which is what you want to learn from conducting your experiment. A hypothesis, which is a kind of prediction of what you believe will happen and why you believe that to be the case. Materials are then listed in a category called apparatus. You can also list materials in a diagram, so long as the diagram is correctly labeled. The procedure, which scientists sometimes call the method, is a detailed list of all of the steps that you need to take in order to carry out your experiment. Data is then gathered and placed in a table so that it is very, very clear to verify and check through. You can then proceed with processing the data and presenting your data in the form of charts or graphs, depending on what is useful and what conveys the ideas in the easiest way. Data that you put into graphs should show relationships that support or refute your hypothesis. By the end of your investigation, you should have enough to write down what happened in the entire experiment and constantly refer back to the hypothesis in order to conclude whether the evidence supports your hypothesis or does not. Read this question, pause the video, and try writing a plan and drawing a table for the information that's given. The question is about some ideas that came about in the 18th century. There were 2 scientists that had different ideas. The one on the left is Priestley, and the one on the right is Lavoisier. You're asked to imagine you want to investigate their ideas. You can assume that you've been given 3 pieces of different metals, and in a laboratory, metals are heated to high temperatures in crucibles. You can also assume that you have access to all the usual laboratory equipment, measuring balances, Bunsen burners, tripods, and so on and so forth. In your plan, you must give the one factor you would change as you carry out your investigation. That's called the independent variable. You must also give one factor you would observe or measure to collect your results, the dependent variable. Give one of the factors you would keep the same as you carry out your investigation, and evidence that would support Lavoisier's idea. After you've done that, try and come up with a table, label it, and show how you could use it to record your results. You can pause the video now. Okay, so variables, evidence, and recording results is something that we need to make sure that we incorporate within our plan. So the independent variable is the one factor you would change as you carry out the investigation. So having read through the information, you realize that it's about metals burning in air. You've been given 3 pieces of different metals, so what you could do is you could change the type of metal that you are going to be investigating, and you could carry out investigations on each of those 3 pieces of different metals. The dependent variable is the one factor you observe or measure to collect your results. So Priestley suggested that when metals burn in air, they lose something to the air and a powder is formed. So that would mean that their mass decreases. Lavoisier, on the other hand, suggested that when metals burn in air, they gain something from the air and a powder is formed. So that would imply that their mass increases. So perhaps what you could do is, for each of the 3 different metals that you have, before heating them, what you could do is you could measure the mass of the metal. You could do this by putting it into the crucible and the lid, and you could measure the mass. But before you do that, you would have to measure the empty crucible with the lid so that you could do a subtraction and work out correctly what the mass of the metal is. And then what you do is you can conduct your experiment. You can allow the crucible and lid with the metal inside to be heated up on top of a Bunsen burner. It's a very strong source of heat, lots and lots of energy going through, so you'll need to have a roaring blue Bunsen flame for high temperatures. Once it's cooled down, you could then reweigh and measure the mass of your product with the crucible and the lid. The lid can keep and stop any of the products from escaping, so you would definitely have all of the mass remaining, and anything that has lost something to the air, you could detect, or whether they've gained something from the air and a powder is formed, you could detect that by an increase in mass. If they've lost something, they would have decreased. If they've gained something, they would have increased in mass. What's quite interesting is that as an extra step, you could reheat it and then allow it to cool down and measure the product with the crucible and the lid again once it's cooled down. And if the mass is the same as the time that you measured it before, it probably suggests that the reaction is over. Now, there are going to be some control variables that you do need to have in place. It's any factor you keep the same as you carry out your investigation in order to keep the test fair. So, it would not make sense to heat one of the metals for a longer period of time over a very strong Bunsen burner flame, while on the other hand, you heat very briefly a different metal at a lower temperature for a shorter period of time. So, in order to even things out, what you could suggest as one example is that you use the same period of time and the same type of flame of Bunsen burner to heat your metals. You can also talk about other things like making sure that the height of the crucible above the Bunsen flame is the same for all three metals. All of these things help you keep the test fair. And finally, any evidence that suggests that Lavoisier was correct would be evidence that you would look out for in the final mass. So once you did your calculations, you could measure the mass of your product, and you could conclude that if Lavoisier was correct, all of the metals would gain mass. They've gained something from the air, and obviously you would have to look at the product, and if they're all powders, then he would be right with that as well. Something that you could think about is, because the metals are different elements, perhaps what we could do is we could measure the percentage increase or the percentage decrease and compare that with our original masses as well. It's not foolproof. The metals do come from different elements. They have different atoms between them and thus different sizes, but it would be enough for us to see this conclusion through. So, drawing a table of results. There is a way in which scientists draw results tables. In the first column on the left-hand side, what we tend to agree on is to place the independent variable. So here we would have a list of the metals. The dependent variable here is highly likely to be the final mass of the metals and the change in mass. So in order to have the change in mass, you would have to have the initial mass that you took, the final mass that you took. You could have the crucible and lid mass when it is empty before it actually contains the metals. That would then enable you to measure the mass of the metal alone. It would also enable you to work out the amount of products and whether there is an increase or a decrease. So what you would have is, on the right hand side, you would have the change in mass for that particular metal that has been heated. So answers I would expect an 11 to 13 year old to write for this question are as follows. So like we said, the independent variable is the metal type. The dependent variable could be the change in mass of the contents of the crucible after burning, or the change in mass of the crucible and its contents after burning. So you could actually have the crucible and the lid with the metal and the products, or you could just work out the change in mass of the metal itself. As something that you would need to ensure that you have as a control variable, you definitely need to make sure that all of the product is weighed. Keeping a lid on the crucible would be useful as well to ensure that nothing escapes. You definitely need to have a starting mass of the metal as being a constant. It's not fair to have twice the amount of metal, for example, with one of the metals. Perhaps the same crucible has been suggested in your own plan, perhaps in the same amount of time. Making sure that you have enough time for the reaction to occur as well are all useful responses for your controls, so in order to make it a fair test. And Lavoisier's hypothesis would be proven if there was an increase in mass following the heating of this of the metals, of all three metals. The mass should increase. We try and steer clear from suggesting that weight increases, because weight is a force, but if you are a young scientist, we can forget that. Any appropriate table in which the results can be recorded would be the next thing to look at. Make sure that you have the type of metal on the left-hand side, and whatever the mass is that you record, it's quite useful for you to put the units of mass in grams in the header as well. But I wouldn't expect a young scientist to look out for that level of detail just yet. You can learn more about Key Stage 3 and GCSE Science, and also watch revision videos, walkthroughs for A-level papers, and a whole host more by subscribing to our channel. Really, really wish you good luck for your tests. I hope you do extra well, and please leave a comment, a like, and a subscribe, and good luck in your tests. Take care, have a great day, bye.